Good morning, good afternoon. This is going to be 4.3 functions. Hopefully get it all in one video. We're going to be able to, I can create a table of values for a function, identify the domain and the range of a function, evaluate functions, and then write rules for functions. So we're going to start with some vocabulary. Function is a relation in which every member of the domain or the input value is paired with exactly one member of the range or the output value. Function notation, the use of the symbol f parenthesis x parenthesis instead of y in an equation to represent the output for the function f for the input x. We read this as f of x. So f of x is read f of x. So if you hear us say or me say f of x, that's what this is. Okay, so what we're going to be doing is we're going to be substituting the known value, and then we're going to be solving. So for this one, find f of -3 if f of x is equal to 2x plus 1. So what we're going to be doing is we're going to, wherever we see an x in this part here, we're going to put -3 in there. And we're going to substitute it. This f of -3, a lot of kids will get that confused with a coefficient, like 2 is the coefficient of x. -3 is not the coefficient of f. F is not a new variable. It's saying what is -3 when I put it into this equation here. So f of -3, the first thing I want to do is I want to substitute that -3 wherever I see an x in this equation. So now I have it substituted, and now I want to solve. Well, first order of operations says I have to multiply first. So 2 times a -3 is a -6 plus 1, and -6 plus 1 is a -5. The pen is running out. So f of -3 is equal to -5. Our next example, f of -2 if f of x is equal to x minus 4. Again, this f of x here is pretty much y. I don't want you to replace it with y, but if you think of it as y equals x minus 4, you are replacing the x with 2 and then solving. So f of 2 is equal to this x, 2 minus 4. So I substitute what I know for x into what x is. So 2 minus 4, that means f of 2 is equal to a -2, because 2 minus 4 is -2. Okay, let's try another one. A little harder. f of 11 is if f of x is equal to 1/2 x plus 5. So we're going to do 1/2, and then instead of x, I'm going to write that 11, and then plus 5. And what is half of 11? That would be 5.5, and then plus 5. So f of 11 is equal to 10.5. Okay. Alright, a function table is a table used to find outputs for given inputs of a function, also known as a table of values. I want you to choose 5, not just 4, 5 values for x to make a function table for f of x is equal to x plus 5, and then state the domain and the range of the function. So we're going to start by creating our table, and we want to use 5 values for x. So remember, this is your x or your input. So you're going to input 5 different values. So I would start at -2, -1, 0, 1, and 2. and then you're going to want to put your function in here. So f of x is equal to x plus 5. And then what is our output going to be? So I want to do, wherever I see the x in this part here, I'm going to put negative, or whatever my input is. So negative 2 plus 5. And then I would get an output of 3. Negative 1 plus 5. Output of 4. 0 plus 5 would be an output of 5. 1 plus 5, 6. And then 2 plus 5 is 7. So we've created our function table with our inputs. We're inputting all of these numbers into my equation here and getting an output. You put something in, you get something out. And then we want to state the domain and the range. So our domain, remember we need our little brackets. We want to write these from least to greatest. So we have written them already from least to greatest, so we'll just copy them. 1 and 2. So our domain is all our x values, and then our range, or our output, is going to get all the numbers that we got out of it. Remember again, least to greatest. You don't want to double up any numbers. So if I had more than one number over here or over here, you want to only write it one time. Okay, again, choose 4 values. Instead of 4, I want to write 5 values for x to complete the function table. For the function f of x is equal to x minus 7, and state the domain and the range. It's done. Alright, so negative 2 and for x minus 7 would be a negative 9. Negative 1 minus 7, negative 8. 0 minus 7, negative 7. 1 minus 7, negative 6. 2 minus 7 is a negative 5. So again, we're going to want to write our domain. What numbers did we input into our equation? We input these numbers all. 2, negative 1, 0, 1, and 2. Okay, and then our range is going to be all the numbers we got out of our equation. So remember, we want to go from least to greatest. So negative 9, negative 8, negative 7, negative 6, and negative 5. Alright, next, the independent variable is the variable for the domain, the x of the function. The domain, remember, it's independent, it can stand alone, and then the dependent variable will depend on what you put into your equation and what you get out of it. So it's also going to be the range. The dependent is going to be your y. So independent, x, domain, dependent, range, y. So we're going to identify the domain and the range. Well, identify the independent and dependent variables. But if you tie the domain and the range together with the independent and the independent and dependent, it might be a little easier. So there are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, P of j, is a function of the number of jars of peanut butter purchased, j. So identify the independent and dependent variables. So the independent is going to be our domain, or our x. In this case, it's our j. So independent, I need a new pen. So independent, j, number of jars, and dependent, the number of peanuts. So which one depends on the other? The number of jars will depend on the number of peanuts. Okay, so what values of the domain and range make sense for this situation? So if you're talking about the number of peanuts, you're not going to put in like 1 or 2. Here, approximately 770. So it's going to be, and you're not going to put negative into it. So the domain is going to be positive, whole numbers, 0 and up. And then the range, if you put 1 into this equation, 770 times 1 is going to be 770. 770 times 2, think about that. So our range has got to be multiples of that 770. Okay, and then write a function to represent the total number of peanuts. So we would want our P of j, meaning number of peanuts, is going to be equal to 770 times the number of jars, so j. And then, so the number of peanuts I'm going to put in here, or number of jars, sorry, I'm going to put in here, and I'm going to get out the number of peanuts in that amount of jars. So if I put 7 into my equation for the number of jars, I would do 770 times 7, so P of 7, meaning 7 jars, is going to be equal to 5,390. I would just do this math, multiply these two numbers. Don't forget to label. You have 5,390 peanuts. Okay, let's do one more example. Scrapbooking store is selling rubber stamps for $4.95 each, and the total sales, f of n, is a function of the number of rubber stamps sold. So identify the independent and dependent variables. So which one will depend on the other? Well, independent is going to be my n. And my n is going to be the number of stamps. And I should have wrote rubber stamps. And then my dependent, which one depends on the other one? Well, it is going to be my total sales, f of n, and that's going to be total sales. The total sales will depend on the number of stamps I sell, rubber stamps. So what values of the domain and the range make sense for this situation? Again, I'm not going to have a negative amount of stamps sold. So my domain is going to be all whole numbers greater than 0. So positive whole numbers. And then that range, again, if I put a whole number into my equation, I multiply it by $4.95. $4.95 times 1, $4.95. What numbers am I going to get out? Well, I'm going to get positive multiples of 495. Okay, now we need a function. Write a function to represent the total sales. Well, the total sales is going to be equal to $4.95 times the amount of stamps I sell, so n. And if I determine the total sales for 5 stamps, do $4.95 times 5, I would get out $24.95, and I should have wrote n here, f of 5, meaning I'm going to put 5 into my equation here, and I'm going to multiply $4.95 times 5, and I get $24.95 for 5 stamps. Work is page 291, 1 through 9 odd, and 15 through 23 odd.